Good day. Welcome back to our third lesson on rules of probability. I want to discuss with you the last rule of probability, and that is independent events. So let's have a look at the meaning of independent events. Now, independent events. Two events are independent if the probability of one of them is not influenced by whether the other happens or not. Now, that still sounds a little bit awkward or difficult almost. So, two events are independent if the one event does not have any effect or influence on the other one. Now, I wrote down two little examples to illustrate, to understand what the meaning is when we talk about two events are independent. Now, it's not so easy to make a drawing to illustrate it like we did in the previous ones, so I would rather discuss it by looking at these. So, first of all, I'm looking at an example of events that are independent. Say, if a person is chosen randomly from a population, event A is the event that the person's birthday is in August, and event B is the event that the person is male, or if you want, you can call it female. A and B are independent since being born in August, that was event A, doesn't make it any more or less likely to be male. So I hope by reading this carefully, you will understand what I meant by saying the one's got no influence on the other one. And I think it is quite clear if you look at this. So if the one event is a person is born in August, the other event is that the person is male or female, it is quite clear that if you're born in August, it's got no effect on the fact of the gender. And that is why we will refer to these two events as independent. Now, secondly, I want us to look at events that are not independent. Remember, our focus is independent events. That is really what we're after. But we want to know, when will two events not be independent? If you get up in the morning and you look outside to see what the weather is like, event A is that it is cloudy. Event B is it will rain later in the day. You can clearly see now that if A is true, then B is more likely to be true as well. So I think it makes sense. No? If it is true that it is cloudy, it is more likely that it will rain. So A and B are therefore not independent. The likelihood of B depends on whether A happens or not. And that is when we could say that these two events are independent events. Now, there is a rule for this, but it's very important to understand that this rule that we have, it's this one, is only true if two events are independent. So, if two events are A and B are independent, this rule will be true. So this rule is not applicable if two events are not independent. It's true that if they are independent. So it's very important to remember that. We can expect questions where they will ask us if two events are independent. Now, to determine if two events are independent, we're going to look at this rule. And if the rule is true, they of course are independent. If it's not true, they are not independent. So I just wanted to give you this explanation on what the meaning of independent, when we talk about independent events, what does it mean? Please remember the rule for independent events is that the probability of A and B, and please remember this probability of A and B is part of your general rule, is equal to the probability of A times the probability of B. So we have a number of rules now. This is the last one of the rules of probability that you need to know in grade 11. The first one, remember, was the general rule. And then we spoke about the special events. That's now mutually exclusive, exhaustive, complementary events. And then the last rule, the rule for independent events. So let's now look at a few examples to illustrate how we're going to use this rule together with some of the previous rules. Right, in our first example, I say here that if A and B are two independent events, please remember they are independent. I just want to highlight that. These two events are independent. Now, the moment we see that they are independent, you will hopefully agree with me. I can say that the P of A and B is equal to the P of A times the P of B. This rule will be true. We don't need to prove it because it's given to us that the two events are independent. Now it's given to us the probability of A, 0.6, the probability of B, 0.3, and the question is to find the probability of OR. So you can see, again, it's about AND and OR, which is our general rule. So I'm just going to write down that general rule again, that the P of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. OR is what we want to calculate. P of probability of A was given to us as 0.6 plus the probability of B was given to us as 0.5. Subtract the AND. And AND was not given to us directly, but they told us that the two events are independent. So that means we can now substitute this AND with the probability of A times the probability of B. It's your choice if you want to work it out separately and then substitute, or substitute first. So while I've got there already written down, I'm going to say that the P of A is 0.6 times by the probability of B is 0.5. And I'm going to multiply this, and that is the probability of A and B, and I can just put it in there. So to multiply this, I hope you are comfortable. Otherwise, you can use your calculator, and that is 0.3. Is 0.6 times 0.5. 6 times 5 is 30. And there are two decimal places, and therefore 0.3. So 0.3. And now we can finish the question easily. A or B is equal to 0.6 plus 0.5 minus 0.3, and that is 0.8. So I hope you can see what is going to happen now. They start to combine the different rules in questions. So instead of giving us the probability of A and B, it's given to us that they are independent, and that means we can find it. Let's look at the next example. In this one, we see that events A and B are such that the probability of A is 0.5, the probability of not B, you remember that was also in one of our previous examples, 0.3, and the probability of A or B is 0.8. And now they ask us, are events A and B independent? So it's not given to us now. We must now go and see if these two events are independent. So how are we going to do that? First of all, this probability of not B, I would like us to use that to find the probability of B. So just to remind you again that the probability of B is equal to 1 minus the probability of not B. You still remember, we can put it the other way around as well. The probability of not B is 1 minus the probability of B. But not B is now given to me, so I'm going to say it's 1 minus this 0,3, and this is 0,7. And that means we now know what the probability of B is. We also have the probability of A. So what we're going to do now is we're going to look at our general rule. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And we're now going to substitute the probability of A or B, because you remember that was given to us as 0,8. The probability of A was 0,5, plus the probability of B is what we calculated before, 0,7. And that means we can now find the probability of A and B. That was not given in the question that we must find it, but you must please remember that we want to determine if these two events are independent. So that means we want to see if the probability of A and B is equal to the probability of A times by the probability of B. Now we know what the probability of A is, and we know what the probability of B is, but we now need to find. We can't say they are equal. That is what we need to calculate. So let's move this one to the left. So that gives us the probability of A and B is equal to 0,5 plus 0,7 minus 0,8. And I hope you agree with me that that gives you 0,4 for the AND. So now we know what AND is. So all we still need to do is we now need to find the probability of A times the probability of B. Please take note, I didn't write down the rule because then it means it's true. We want to see if this rule is true. The probability of A times the probability of B, that is 0,5, times by 0,7. And when we multiply that, your answer, because 7 times 5 is 35, and we need 2 decimals, and your answer is 0,35. And what do you notice? It's quite clear that we now can say that the probability of A and B is not equal to the probability of A times the probability of B. So this is a very important question, very popular in grade 12 exams as well, that they ask us sometimes to prove or show if two events are independent, and that is how we do it. We first find the probability of A and B, and then separate from that, we find the probability of A times the probability of B. And if those two sides are equal, then it means they are independent. In this particular example, we will say that A and B, that's now the two events, A and B are not independent. And now I hope you can see after these two examples how they can change these questions in different ways. But we're not finished yet. There's still another one. This one is a typical grade 11 or grade 12 question in probability. And let's read and see. Given two events, x and y, such that the p of x is 0,4, the p of x or y is 0,7, they ask us to determine the probability of y if the two events are mutually exclusive. So take note, this question's got two parts. First of all, we're going to look at what the p of y will be. That is what we're going to find if the events are mutually exclusive, and secondly, if they are independent. Now, what do we know about mutually exclusive events? We know that there's no intersection, so that means that the p of x and y is equal to 0 because of mutually exclusive. So now our general rule, the probability of x or y is equal to the probability of x plus the probability of y minus the probability of x and y. Our question is to find the probability of y. That is the question. So let's see. Probability of x or y was given to us, 0,7. Probability of x, there it is, 0,4. Plus the probability of y, please remember that is my question, minus the probability of x and y, and we said already that is 0. And just to remind you again, why? Because the two events are mutually exclusive. So that is 0. And I think it's quite easy now to calculate the probability of y, which is just that 0,7, subtract the 0,4, which is 0,3. So that is the probability of y if the two events are mutually exclusive. What about if the two events are independent? So the given information is still there. Probability of x, we still use that. Probability of x or y, we still use that. And we're going to calculate the probability of y, but now instead of that the two events are mutually exclusive, the two events are independent. Now, if they're independent, you will remember what we said before, that the probability of x and y is equal to the probability of x times the probability of y. So let's just write down the general rule. Probability of x or y is equal to the probability of x plus the probability of y minus the probability of x and y. So now let's see what we have. Probability of x or y, still remember, that was 0,7. Probability of x, 0,4. Probability of y, remember that is the question, so I'm going to leave it, minus. And what do we know about probability of x and y? That will be the same as the product. So I'm just going to use square brackets here. So I'm going to substitute the probability of x and y by the probability of x times the probability of y. So let's now, in the meantime, take this 0,4 to the left. So this will become 0,3. And that is then the probability of y minus that probability of x, please, is the same as what was given to us as probability of x is 0,4. So it's 0,4, and we can leave the brackets there. And we multiply this by the probability of y, which we don't know. So you can see this equation a little bit more difficult than the previous ones. So let's now see if we can get to the probability of y. So we have the probability of y, subtract 0,4 probability of y. This we can subtract. like we do in algebra. They're called like terms because there's one of these, minus 0.4. So that means we're going to get 0.6 probability of y. Remember, there's a multiplication, 0.3. And now it's easy for us to find the probability of y because we're just going to divide by 0.6. So I get 0.3 divided by 0.6. And I hope you can see what this will be. This answer then, of course, you can write it as a half, or if we stay with decimals, the answer will be 0.5. So that is the probability of y if the two events are independent. The probability of y was 0.3 if the two events are mutually exclusive. A very important question. Make sure you understand this very well. Thank you.